All right, grade nines, the live stream didn't work, so I'm gonna pre-record and upload, as I usually do. This was the homework I gave you Friday. It was to do a second mock test. Whoops. Second mock test. The questions were 138, 43, 47, and 50. So there's an extra one in here, 45. I think I left it on anyway. And I just realized I skipped 43 for you. Just let me double check to make sure I've got the right ones. 38, 40, 46, 50. Sorry. 38, 40. 38, 40, 46, 50. That's what I gave you. Okay. 38, didn't do 40, 46, and 50 is here, so I skipped over 40. I'll do that for you now. So I mixed up some of the questions from the other class. They're similar questions, but I gave you different ones. So I'll do 40 for you. Space. So in question 40, we'll have it here ready for when we get to it. The first one I gave you was 38. It was a simple question. All you have to do is identify how many significant figures are in those numbers. So here there's 5. This one only has 3. The zeros that are trapped between numbers count as significant figures. On these ones, the zeros also count because they've been written after the decimal place, so it means you've measured to that level of accuracy. So those count. That's 4 significant figures. This also counts as 4 significant figures. These also are 6 because if you bother to write the extra 0 after a decimal place, it means you measure to that level of accuracy. If they're added after before the decimal place, then they're just placeholders, and you can rewrite the number as a scientific notation to convince yourself of the actual number of significant figures. If I was to rewrite this number as a scientific notation, I would get 3.07 times 10 to the power of 2. That's 3 significant figures. So if a 0 is written after the decimal place, it is significant. It's not just a placeholder. It's there because the person measured to that level of accuracy. The next question is 140. It says the diameter of the Earth at the equator is 7,926.381 miles. Round this number to 3 significant figures. So 7,926.381, and you want to round it to 3 significant figures, and then express it in standard exponential notation. So if you want to go to 3 significant figures, you're going to cut it off here, which means it's going to be, and because this number is a 6, you're going to round up the 2 to a 3. So you're going to get 7,930. That's 3 significant figures, or you could express it as 7.93 times 10 to the power of 3. Both of these would be correct. If I was to put a decimal place here, that would become 4 significant figures. But because I didn't put the decimal place, that's only 3 significant figures. You don't count that 0. B. It says the circumference of Earth through the poles is 40,008 kilometers. Round this number to 4 significant figures and express it in standard exponential notation. If I was to round it to 4 significant figures, I would say 40,010. Or I could rewrite it as 4.001 times 10 to the power of 4, because I would move the decimal from here to there, so that's 4 jumps. The next question that you need to look at was 46. 46 is over here, so I'll do it. I'll move you over. And I'll keep you to the side so you don't get the glare from the window. I still have to cover that window pane with some paper, because the blind fell off. So 46, it says the speed of light in the vacuum is 2.998 times 10 to the power of 8 meters per second. Calculated speed in kilometers per hour. So we have to go to kilometers per hour. We're gonna first tackle meters. There's 100 centimeters per meter. There's 1 inch per 2.54 centimeters, 1 foot for every 12 inches, 1 mile for every 5,280 feet. And then there's 3,600 seconds per hour. So what I did is I tackled each successive unit with the appropriate conversion factor that brings me closer to my target, which is miles per hour. I'm gonna look at one thing at a time. The first thing I looked at was meters. So I canceled meters by putting meters in the denominator. Don't worry about centimeters for now. I'm just heading in the general direction of miles. Then I got rid of centimeters. Then I got rid of inches. Then I got rid of feet. And finally, I tackled the seconds. Seconds had to be canceled with 3,600 seconds per hour. So now I have miles per hour left over. That's my target unit. When I enter it into my calculator, I say this number times 100 divided 2.54 divided 12 divided 5280 times 3,600, and what you get is 6.706 times 10 to the power of 8, or 670,633,500 miles per hour. That's the speed of light, the fastest thing in the universe. If you write it to 4 significant figures, it turns to 6.706. The 3 rounds down to 0 because it's closer to 0 than it is to, if it's below 5, you round down to 0. If it's 5 or higher, you round up to the next number. So in this case, we stayed down to 6. So 6.706 times 10 to the power of 8 miles per hour would be your final answer to the correct number of significant figures. B of 146 asks, the Sears Tower in Chicago is 1,454 feet tall. Calculate its height in meters. So we're starting off at feet, and we're going to cancel feet by turning them into inches. Then we'll cancel inches by turning them into centimeters. Then we'll cancel centimeters by turning them into meters. And we are at our target, which is meters. 1,454 times 12 times 2.54 divided 100 gives you that. Now, when you enter it in your calculator, you could say 1,454 times 12 divided by 1 times 2.54 divided by 1. But like I've told you before, don't bother dividing or multiplying by 1 because you get the same number. So just enter the parts that are actually going to affect it, and you'll get the correct answer. And then when you report it to 4 significant figures, you get 443.2 meters. In C, you're asked, the vehicle assembly building at the Kennedy Space Center in Florida has a volume of 3,666,500 meters cubed. Convert this volume to liters and express the result in standard exponential notation. So I'm going to first convert to liters by canceling meters. There's 1,000 liters per meter cubed, and that's it. We're there. You add 3 zeros to the original number, and you get 3,666,500,000 liters. If you write it to 5 significant figures, why would I do that? Because 5 significant figures is what I have. So 3.6665 times 10 to the 9 liters is your final answer. D. An individual suffering from a high cholesterol level in her blood has 232 milligrams of cholesterol per 100 milliliters of blood. If the total blood volume of the individual is 5.2 liters, how many grams of total blood cholesterol does the individual's body contain? So here we go, 232 milligrams per 100 milliliters of blood. There's 1,000 milliliters per liter, so that allows us to cancel milliliters. There's 5.2 liters total amount of blood. That cancels with the liters here. So the final answer is going to be in milligrams. You get 1.2064 times 10 to the 4. When you multiply by that, divide by 100, multiply by 1,000, multiply by 5.2, you get this number. Now we're going to turn it back into grams by dividing by 1,000 milligrams per gram. It allows us to cancel grams. The final answer is in grams, 12.064 grams of cholesterol. You're only allowed 2 significant figures because you only have 2 significant figures here. So your final answer is 12 grams. You truncate that part off because it makes no sense to report it to that level of accuracy when they've basically given you the volume of blood as 5.2 liters, which is 2 significant figures. 1.50, A, if an electric car is capable of going 225 kilometers on a single charge, how many charges will it need to travel from Boston, Massachusetts to Miami, Florida, a distance of 1,486 miles, assuming that the trip begins with a full charge? Oh, I didn't see that because I answered. Okay, you'll see what I did. So, it's 1,486 miles. And the conversion factor from miles to kilometers is 1.609344. I could do a big long calculation where you go through feet and inches and centimeters, but I just looked it up in this case. Sometimes you can do that, just look it up and Siri will tell you the exact conversion factor. That's what it is. There's exactly that number of kilometers per mile. One charge every 200 brings the car 255 kilometers, so that's going to allow us to cancel kilometers. And that means you need 9.378 charges if you start off with a charge. So it'll be charged at least 9 times before arriving at its destination. If it started out with a dead battery, then it will require 10 charges, but it says in the question that it starts off with a charge. Because the last charge, the beginning of the 10th charge, will be used only partially. So the next question, 150B. If a migrating loon flies at an average speed of 14 meters per second, what is its average speed in miles per hour? So we start off with 14 miles per hour. There's 3,600 seconds per hour, so that allows us to cancel seconds. There's 1 kilometer per 1,000 meters, that allows us to cancel meters. And that's going to give us all right, and there's 1 mile per 1.609 kilometers, so kilometers cancel, turns into miles per hour. 31 miles per hour when you're only allowed 2 sig figs. And we'll go back to this board because I don't want to erase what's below the next one, which is 150C now. 150C, the question asks, what is the engine piston displacement in liters of an engine whose displacement what is the engine's piston displacement in liters of an engine whose displacement is 450 inches cubed? Let's just check for glare. No, that's no good. Let's put it over here. Even worse. And that's tolerable. We'll leave it like that. So if you have an engine displacement of 450 cubic inches, what are they asking you to convert it to, though? Liters. So you're going to say there are 2.54 centimeters per 1 inch, but we're going to raise that to the power of 3. And then we're going to go to 1 milliliter per 1 centimeter cubed. We just have to know that by heart. Times 1 liter per 1,000 milliliters. And that will give us our engine displacement in liters. What we get is 7.3741788 liters, and we're going to go to 2 sig figs because we start off with 450. That's only 2 sig figs. If they had put a decimal, it would have been 3 sig figs, but with the 0 there and no decimal, that's only 2 significant figures, so we're going to say 7.4 liters. That's a big engine. And D now. That was C. The last one on 150. It asks, in March 1989, the Exxon Valdez ran aground and spilled 240,000 barrels of crude petroleum off the coast of Alaska. 1 barrel of petroleum is equal to 42 gallons. How many liters of petroleum were spilled? So we start off with 240,000 barrels. Times 42 gallons per barrel times 3.8785, I'm gonna use US gallons, 412 liters per US gallon. I'm gonna say that, I'm gonna specify because there's imperial gallons, that's what we use in Canada. Our gallons are bigger than American gallons, just remember that. What you get is 3.815, 695, 3 times 10 to the 7 liters. 2 sig figs means 38 million gallons, 38 million liters of oil. It was messy. Then, okay, I'm gonna stop there and I'm gonna restart and make a separate video for the periodic table because I don't want it to get too long because that takes too long to upload.